Okay, in this video we're going to look at the binomial expansion. Last year, this is what we found out when we looked at our binomial expansion. We had our a plus b to the power of n. It was equal to a to the power of n. So really what this is, remember, this is just the same as nc0 times a to the power of n, b to the power of 0. That's really nc1 times a to the power of n minus 1, b to the power of 1, and so on. So a couple of things are important. The powers, these two powers always add up to the n. So n plus 0 adds up to n minus 1 plus 1 adds up to the n minus 2 plus 2 adds up to n minus r plus r adds up to the n. And this is a general term, which we saw last year, and that was quite important as well. For this one, this is for a positive n being a positive integer. However, if n is a positive integer, this expression n1, n2, nr, or ncr as we would call it, does not work for a negative number or else a fractional number. So it just does not work. So we have to have a different way of looking at that. We also have, so we're going to look this year, we're going to look really at expanding 1 plus x to the power of n, and also that is where that's where this n is either a fraction or a negative number. And there's also a condition we're going to have to put on this, which your x value, so whatever this thing is here, has to lie between -1 and 1. I will talk more about that when we get on to the numerical examples. Okay, basically what we have in a formula booklet, this is, and remember, we're going to look at expansion 1 plus x to the power of n, and we've just said this thing, which is remember, that's your nc1 or nc2. These don't really exist if n is a negative or fractional, so we're going to have to look at a different way of doing it. So we're going to change this thing, and this thing can be written a different way, so it could be written as this. We do not need the proof of this anymore, thankfully. So we can just, this is given in your formula booklet, and we can just use this, and we're going to see how exactly we do that in these examples. And again, there's another note which is important here. If it is not in the form 1 plus something to the power of n, you need to get it in that form. So for example, if I had 2 plus 3x and it was the power of, we'll just say to the power of -1, I want to get it back in this sort of form. So what I'm going to do is take out a 2, and then that becomes 1 plus 3x over 2, and I'll put a square bracket around that. That is all to the power of -1, and then that would be 2 to the -1 times 1 plus 3x over 2, all to the power of -1, and 2 to the power of -1 is the same as a half, so it's really a half upon 1 plus 3x over 2, all to -1. Okay. Definitely easier to just jump to the numerical examples and see how this works. It's very confusing just looking at it algebraically. Okay, in these examples it says expand the following in ascending powers of x. So that means starting with your lowest power of x and moving up and giving the first 4 terms. State also the range of values of x for which it is valid. So remember what we've just said. If you had 1 plus x to the power of n, it's valid whenever -1 is less than x is less than 1, or another better way of saying it is modulus of x is less than 1. Okay, so that's really what that's talking about there. So the first one's dead easy to see, the second one not so easy. Okay, we're going to zoom in on the first example, and then we'll get started it. Okay, so first one's a nice easy example. It is pretty much in the form that we want. Remember, 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 times x squared, all divided by 2 factorial, plus n upon n minus 1 times n minus 2 times x cubed, all divided by 3 factorial, and so on. It goes on. But if you look at this, a couple of things just to make this very easy. The power of this is 1. We don't need to write in, but the power of this is 1, and there's one thing multiplying the x. The power of this x is 2. And there's 2 things multiplying the x. And notice as well in the bottom, it's 2 factorial. The power of this x here is 3, and there's 1, 2, 3 things multiplying it, and the bottom line is 3 factorial. Another thing which makes it is a wee bit strange, you go as far as you've n minus, you have multiplying here. First one is n times x, next one is n times n minus 1, and this is minus 1, which is always going to be 1 less the 1 here. The thing that's being taken away is always 1 less than this power. Likewise, in this one you have n times n minus 1 times n minus 2, and again the last thing that you're taking away is always 1 less than the power. So a couple of things to help us get through this. Okay, so in this one, I'll just write it out again. What do we have? 1 plus x to the power of a half is equal to, my first term is always just 1, and then it's n, and in this case my n is a half, so a half, use brackets in these, brackets are your friend, and then times x to the power of 1. I wouldn't normally use a bracket for that bit, to be honest, but I will just for this case, and then that's going to be a half, that was my n, and then the next bracket is n minus 1. Now my n's a half minus a half, a half minus 1 would be minus a half, and then that's times x squared, and then that's divided by 2 factorial, and then plus, that's going to be a half is my n minus 1 would be minus a half, and n minus 2 would be a half minus 2, which would be minus 1 and a half, but write it as minus 3 over 2, it makes it much easier. And then that's still x cubed, all divided by 3 factorial. Now, you can just fire this into your calculator. I'm just going to show the working out for the sake of it here. The first one, that's just 1, and then a half times x, that's just the same as x over 2. And then over here, I'm going to have a half times minus a half would be minus a quarter, and then that's times the x squared, and then 2 factorial is going to be 2, and over here that's going to be it's going to be a half times minus a half, which would be minus a quarter, and then times minus 3 over 2, which would be plus 3 over 8, and then that's times x cubed. Sorry, I don't need that bracket around that anymore. Times the x cubed, and 3 factorial is 1 times 2 times 3, which is going to be 6. Okay, if we move on from that, that's going to be 1 plus x over 2. You have minus a quarter divided by 2, which is going to be minus an 8, so it's x squared over 8. And then this is going to be 3 over 8 divided by 6. You can do that in your calculator if you need to, but it's just the 3 is going to cancel into the 6, and then you're going to be left with 1/8 divided by 2, which is going to be 1/16, so x cubed over 16. Okay, we have done the expansion part of that. We're just left to do the validity of it, so where this thing is valid. So it is valid for, and there we have it, it's in that form, 1 plus x to the power of n, so it's valid for modulus of x is less than 1. That's the way I would prefer you to write it, but you can write it as x minus 1 is less than x is less than 1, but definitely that's a nicer way of doing it. Okay, in this example, we've got a slightly different setup. We do not have it in the form 1 plus something to the power of n. So what we've got to do is take this 2 outside, reduce this 2 to 1, so we need to take a 2 outside. So the thing really becomes 2 upon 1 minus x over 2, and put that in a square bracket, so that whole thing is the power of minus 1. So that really is 2 to the power of minus 1, and then 1 minus x over 2 to the power of minus 1. And I'll just do one more line before I get started expanding. That 2 to the power of minus 1 is a half, so it's 1 minus x over 2 to the power of minus 1. Okay, if we expand that, we're going to have a half is going to be multiplying the whole thing, and then it is 1 plus my n is minus 1, and what we have in this first bracket is going to be minus x over 2. So that's 1. What we have here is this is the 1 plus the n times what was normally the x, but it's not x this time, it's minus x over 2. The next bit is going to be brackets minus 1, that's my n, then n minus 1 is going to be minus 2, that's going to be minus x over 2, and that's squared, and this is divided by 2 factorial. And the last term for us is going to be minus 1 times minus 2 times minus 3 times minus x over 2, and that's cubed, and that's divided by 3 factorial, plus dot dot dot. You don't have to put any more terms in because we've got 1, 2, 3, 4 terms, so we're good. Okay, so we've still got our half inside, and we're just going to do this out. Again, normally I'd probably just fire this into the calculator, but just to show us a few places where people would slip up here. You've got 1 as the first term, then minus 1 times minus x over 2 is going to be positive x over 2. And then here inside, you've got minus 1 times minus 2 is going to be 2. And then you've got minus x over 2 squared. Minus x squared would be, minus x all squared would be x squared. 2 squared on the 2 in the bottom line squared would give you 4, and the 2 factorial is 2. So that's what you have for your third term. And next one, let's just sort out the minuses first of all. You have a minus thing cubed, which would give you a minus, and times a minus will give you plus, times a minus will give you minus, times a minus will give you plus. So it is going to be a plus here. So we're just going to do the minus 1 times minus 2 times a minus 3, which is going to give you minus 6. And then it's going to be inside this bracket, it's going to be minus x cubed. And then the 2 cubed as well gives you 8. And the bottom line, 3 factorial is going to give you 6. So you can see nice things which will cancel out here to make life an awful lot easier. We'll do it in a different color just to show us that can cancel, and that 6 can cancel, and that can cancel. So what you're left with is a half upon 1 plus x over 2 plus x squared over 4, and then plus, because that is minus times a minus, make that plus, so plus x cubed over 8. And your last line for your expansion, multiply in by the half, you're going to get a half, plus x over 4 plus x squared over 8 plus x cubed over 16, and so on. Okay, now this one is valid. Go back to the expansion where you had it in 1 plus x form, or 1 plus whatever form I should say. I always talk about it as being 1 plus squiggle to the power of n is valid when modulus of squiggle is less than 1. Okay, so here the squiggle effectively is minus x over 2. So valid for modulus of minus x over 2 is less than 1. And then that's just the same as modulus of x over 2 is less than 1, and that's not very pretty, so that becomes multiply across by that 2, and you're going to have modulus of x is less than 2, and that's it. Okay, this is a tricky question. It says, given that x is so small that x cubed and higher powers of x may be neglected, find 1 over the square root of 1 plus x, and hence by letting x equal 5 over 16, find a rational approximation for root of 21. Okay, if you look at this and you think, I have no idea how we're going to do this last bit, rational approximation for root 21, we're all in the same boat. You're not going to just see this and understand how to do it. So just get started doing the first bit, do the expansion of this thing, and then hopefully something clicks and we'll be able to get there. Right, so we're just going to write down, first of all, we had 1 over the square root of 1 plus x. Let's get it in that form, 1 plus something to the power of n. So that would be the same as 1 plus x to the power of minus a half. So we've got to do the expansion of this thing. I'm just working across a page here because I would need a bit of space to do the next bit. If I do that out, I've got 1 plus my n is minus a half times my x plus my n is minus a half, n minus 1 then would be minus a half minus 1, which is minus 3 over 2 times my x squared, and that's all over 2 factorial. And then we'll go on from here. Okay, right, it says x cubed and higher powers may be neglected. Happy days, that means we don't need to go any further in this expansion. So save yourself a bit of time and effort and read what it says here so that you don't do unnecessary work. So if you tidy this all up, and I'm just going to do this in one line here, you have minus a half times x, that's just be minus x over 2. Then do this in your calculator, just minus a half times minus 3 over 2, and divide it by 2 factorial, which remember is 2. You will get 3/8, so 3 over 8. And you've got x squared, which will be on the top line. So that's what you have as your expansion. Okay, right. Tricky bit then says, hence by letting x equals 5 over 16, find a rational approximation for root 21. Haven't a clue. So let's just get started and hopefully something sparks. To say when x is equal to 5 over 16, that means 1 over the square root of 1 plus x would be the same as 1 over the square root of 1 plus 5 over 16. And if you do that, that's 1 over the square root of 1 plus 5 over 16. 1 is the same as 16 over 16. So 16 over 16 plus 5 over 16 is going to be 21 over 16. Okay, this should be giving you a wee bit of confidence because you've now got a 21 and in particular a root 21, I suppose, and a root 21 here. So it looks like we're on the right track now. Okay, if we just sort this out, that's the same then as 1 over, that's going to be the square root of 21, and 4, I'll put that in a bracket to make that a wee bit clearer. And 1 over this thing, just reciprocal it, so flip it upside down, that's going to be 4 over root 21. Okay, so we know when you put 5 over 16 into the left-hand side of this expression, you get 4 over 21. So a sensible thing to do would be put 5 over 16 into the right-hand side, so into this expression, and see what we get. So just say, I'll just tidy that up, cut that off a wee bit, and just say when x equals 5 over 16, 1 minus x over 2 plus 3x squared over 8 is equal to 1 minus, it's going to be 5 over 16 divided by 2, which is going to be 5 over 32. And then plus I'll show my working out for this next bit. That's going to be 5 over 16 squared. And again, from here, fire that into your calculator and see what you get. So you get 1803 all over 2048. Okay, right. So our left-hand side was equal to 4 over root 21. The right-hand side was 1803 over 2048. So that tells you that those two things must be equal. So 4 over root of 21 is equal to 1803 divided by 2048, and then just multiply across. So I'm just going to bring that thing across here. It's going to 2048 is going to multiply across the 4, and that 1803 is going to come down, and then the 21 is going to go across. So really what you're going to have is just going to be, in fact, I'll do 2 steps here. I'll just do that across. That's going to be 1803 over 2048 upon the root 21. So I've just brought the root 21 over, and then you can just do this. It's not nice looking, but it's fine. This is what the calculator is for. 2048 is going to be equal to root 21. So just divide it back across by that fraction, ugly looking fraction, and therefore you get your answer, root 21. And it says find a rational approximation. So that means you've got to leave it in numerical form. And if you do that on your calculator, you're going to get, and it worked out to be as a top heavy or a mixed number, 4 over 980 over 1803. Okay, done. Okay, this example says expand 1 plus 2x squared all over 2 minus x in increasing powers of x up to including the x cubed term, and state the range of validity. So we have to first have a wee look at this. It doesn't look like it's in the form that we're used to at all. So we're just going to say we have got 1 plus 2x squared all over 2 minus x. And you could write that as 1 plus 2x squared upon 2 minus x, and that is the power of minus 1. So you've got that thing off the denominator to the numerator as 2 minus x, the power of minus 1. Now we're not good to go just yet, because we really only can expand something that's in the form of 1 plus squiggle, as I said, to the power of n. So here we've got to take this 2 outside this bracket. So this 2 needs to come out. So I'm going to say that's a square bracket times 2 has come out. Then you're left with 1 minus x over 2. And that's now to the power of minus 1. And we will now have a wee go at that. And that is going to be 1 plus 2x. That's all being squared. The 2 to the minus 1 is going to be a half just, and then times 1 minus x over 2, and it's the power, 1 minus x over 2, and it's going to be the power of minus 1. Right, let's go ahead and do that. That's a half, 1 plus 2x squared, and expand this thing. We'll see what we're going to get. You're going to have 1 plus minus 1 times minus x over 2 plus minus 1 times minus 2 times minus x over 2 squared. That's divided by 2 factorial, and plus minus 1 times minus 2 times minus 3 times minus x over 2 cubed, and that's divided by 3 factorial. Okay, we don't have to go any further than this. We had to go up to and including terms in x cubed. So that's as far as we need to go. Right, a couple of good lot to do still, I'm afraid, in this one. Just write out the first two bits, so the half and the 1 plus 2x all squared, and then we're going to tidy up in here. Okay, we're going to talk through how we do this, and if I want to do this as I would in an exam, so I wouldn't be really doing any more extra work here at all. I would just be writing down the answers here. So using your calculator if you want. So 1 is the first term. Next term is minus a half times minus x over 2, which is just going to be positive x over 2. Nice and easy. Then you've got, we'll sort this bit out first. You have minus x squared on the top line, which will be positive x squared. You have a 2 on the bottom line, and it's being squared, so it's going to be it's going to be positive x squared over 4. And then multiplied by minus 1 times minus 2, and then divided by another 2. So really what you've got is 2 upon x squared over 4, all divided by 2. So on your calculator, how I would do that on my calculator, I would forget about the x bit. I would say really what I'm doing is minus 1 times minus 2 times, that's just be minus a half squared, and then divided by the 2 factorial. So put that into your calculator to get the numerical part, and then just remember that you've got an x squared term. So if you do that, what you're going to have is a quarter. So then you've got the x squared bit, so x squared over 4. Same idea for this one. On my calculator for this one, if I was doing this one on my calculator, what I would really put in on my calculator is I would just do minus 1 times minus 2 times minus 3 times minus a half cubed. Fire that all over 3 factorial. And then remember, you've got the x cubed term as well. So when you did that, I have got x cubed over 8. Okay, now we have a good bit to do still. We still have to expand this term out. So if you expand that out, that's just a normal quadratic. A lot of people go through trying to do this using a binomial expansion. That is just normal quadratic. Expand that as you would, normal expanding brackets as you would have you done since year 11. So that's be 1 plus 4x plus 4x squared. And then that's upon 1 plus x over 2 plus x squared over 4 plus x cubed over 8. Right, now from here on in, this is where we have to be really smart. We only want to go up to the terms including the x cubed. So the 1 can multiply in everything in this bracket. The 4x can multiply this, will give you a linear term. It would multiply this, give you a quadratic term. Multiply this, would give you a cubic. But if you multiply 4x multiply this term, it would give you an x to the power 4 term. So we don't need to go that far. Likewise here, the 4x squared can multiply the 1. It can multiply the x over 2. But 4x squared times the x squared term would give you a power of 4, x to the power 4 term. So that's gone too far. So you don't need to multiply out everything, just be sensible on what you multiply out. Okay, so if you do that out, what you're going to get is 1 plus x over 2 plus x squared over 4 plus x cubed over 8 plus 4x. So this is my 4x times 1, and then I'm doing 4x times x over 2, which is going to give you 2x squared, and then 4x times x squared over 4, which is just going to give me x cubed. And then this is my 4x squared times 1, so 4x squared. And then this is my 4x squared times x over 2, which is just going to be 2x cubed, plus dot dot dot. So notice I haven't gone beyond, done any more terms. I haven't gone beyond my cubic terms. Last thing to do is tidy up and then multiply out by the half. So tidy up, you're going to have 1 plus 9x over 2. Yep, 9x over 2 plus 25x squared over 4 plus 25x cubed over 8, and so on. And then you can multiply in by the half just. Have I any room below here to do this? I have loads of room below. Really wasting my, not using my space well. So that's going to be a half plus 9x over 4 plus 25x squared over 8 plus 25x cubed over 16. Okay, let's look back at what the expansion was. Here, this bit here, up top, sorry, this was a bit that we were expanding. So 1 plus, sorry, this thing here, it was 1 plus x over 2. So what we want really in this thing, we want to say that this is valid. So it is valid for the minus x over 2. Modulus of minus x over 2 is less than 1. Remember, that's the same as modulus of x over 2 is less than 1, which then gives you modulus of x is less than 2. Okay, next one says find the first three non-zero terms of the binomial expansion of 1 plus x minus 6x squared all to the power of minus 1. Okay, it's not in the form that we're used to. The form we're used to is 1 plus squiggle to the power of n. So it's not in this form. So we're just going to rewrite it and let's make it in that form. So we're just going to say let 1 plus x minus 6x squared to the minus 1, let that be equal to 1 plus, and I've just forced a bracket in this thing, x minus 6x squared goes into a bracket, and then that's all to the power of minus 1. So if you'd expanded this thing, remember that would be 1 plus n times squiggle plus n times n minus 1 times the squiggle, whatever it is, squared, divided by 2 factorial, and so on. So in this case, the squiggle really is equivalent to the x minus 6x squared. So if you expand this thing out, you're going to get 1 plus, my n was minus 1, times x minus 6x squared, plus minus 1 times minus 2 times x minus 6x squared, and that's going to be squared, all divided by 2 factorial. Okay, now let's think about what this question asks, because we don't want to do more work than we need to. It says the first three non-zero terms. So the first three non-zero terms, there's going to be a numerical term. There's definitely going to be a numerical term. There's going to be a linear term, minus 1 times x would give me a linear term. And then there's going to be a quadratic term, minus 1 times the minus 6x squared is going to give me a quadratic term, and I imagine there's going to be a quadratic term in this as well. So that's as far as we need to go. So we'll just work through with this. No point in doing any more here. It's not going to get you any bonus marks. So here we'll go on and we'll think that's 1, and then minus 1 times the x is going to be minus x, minus 1 times the minus 6x squared is plus 6x squared, and then you've got minus 1 times minus 2 is going to be plus 2 divided by 2 factorial, which is 2, so that just cancels out, so happy days, that just goes. So really what this the last bit here becomes is just x minus 6x squared, and it's squared. So we'll just go through all that, multiply or square out the bracket, I should say, and that's going to give you x squared minus 12x cubed plus 36x to the 4th. Okay, we're going to look at an example here where the first thing we've got to do before we can do our binomial expansions is to rewrite something using partial fractions. So our example says, express 2 plus x all over 1 plus 2x upon 1 minus x in partial fractions, and hence find the first 4 terms in the series expansion and then state values of x for which the series is valid. So the first thing we've got to do is a partial fractions bit, so we're just going to say let 2 plus x over 1 plus 2x upon 1 minus x, that's a 1 minus x there, be identically equal to a over 1 plus 2x plus b over 1 minus x. So that means, and this is, remember this is just multiplying across by this denominator, you'll have 2 plus x is identically equal to a times 1 minus x plus b times 1 plus 2x. Remember, there's only 2 ways we can do these partial fractions. We can equate coefficients, or else we can substitute in values. So I'm going to do the substitution in values bit here for this one. I'm going to say let x equal 1. So what I mean by this is I put x equal to 1 on both sides. So my left hand side is just 2 plus x, so that becomes 2 plus 1, so it's just 3. My right hand side is going to be a times 1 minus 1, which is just 0, plus b times 1 plus 2 times 1, so 1 plus 2, so b times 3. So you've got 3 is equal to 3b, therefore your b is equal to 1. So find one of my unknowns. Next thing I'm going to do is find the other one. I'm going to, how will I do this? I'll do this by equating my coefficients, and I'll equate coefficients of x to the power of 0. So remember, x to the power of 0 means your term which doesn't have any x's, it's the numerical term. So on my left hand side, numerically I've got 2. On my right hand side I have a times 1, which is just going to be a, and I have b times 1, which is just going to be b. So, and we know that already that b is equal to 1, so that means 2 minus 1 is equal to your a, and a is also equal to 1. Okay, so what have we found out so far? We have found out that 2 plus x all over 1 plus 2x upon 1 minus x is really just the same as 1 over 1 plus 2x plus 1 over 1 minus x. Right, so what we now need to do is use our binomial expansion. So first of all, this first term could be written as 1 plus 2x to the power of minus 1, and my second term, same idea, could be written as 1 minus x to the power of minus 1. So we've got 2 expansions to do here, so it's going to take me a fair bit of room to do. So my first one, so this is expanding this one here, it's just going to be 1 plus minus 1 times the 2x plus minus 1 times minus 2 times the 2x, and the 2x is squared this time, that's divided by 2 factorial. And I think if one more to do, I've got to go up to the cubic term, so minus 1 times minus 2 times minus 3, and that's times 2x, and that's going to be cubed, and that's divided by 3 factorial. It doesn't matter in this particular case because they're both adding, but just put a bracket around. Sometimes one of them is taken away, being taken away from the other one. And really I should have had a couple of wee dot dot dots to show that that's an infinite series. Okay, same idea for this one over here. I'm going to have 1 plus minus 1 times the minus x, is my squiggle in this case is minus x, and then plus minus 1 times minus 2 times minus x, and that's going to be squared and divided by 2 factorial, and then plus minus 1 times minus 2 times minus 3, squeezing this in here, and that is going to be minus x cubed, and that's over 3 factorial. Okay, tidy that up because that's a bit of a mess, and you're going to have, I'll leave it in brackets still, that's going to be 1 minus 2x, And then if you do these out, that's going to be minus 1 times minus 2 is 2, divided by the 2 factorial, which is 2. That just disappears, so you're just left with doing 2x all squared. So that's going to be plus 4x squared. And then here, you have minus 1 times minus 2 times minus 3, which is going to be minus 6, and divided by 3 factorial, which is 6. So minus 6 divided by 6 is going to be minus 1. And then here you've got 2x all cubed, which is just going to be 8x cubed. Same idea at the next bracket. You're going to have 1 minus x, and then you've got minus 1 times minus 2 is going to be 2 divided by 2 factorial, so they just cancel out. And then minus x squared would be positive x squared. And here you've got minus times a minus times a minus, so 3 minuses and a minus x cubed. So that's going to be positive overall, and minus 1 times minus 2 times minus 3 is going to be the 6, and divided by 3 factorial by 6, so that's going to be positive x cubed. And that is it. Okay, tidy that up. You're going to have 2 minus, oh, that should have been a plus x there. Sorry, that's a plus x. So 2 minus x then, and then that's going to be plus 5x squared, and then minus 7x cubed, and so on. Okay, the question said, for what is this valid for? So you have 2 things to look at here to say what it's valid for. So the first one is this thing. So it's valid for modulus of 2x is less than 1, and it's also valid for this one as well. So you have 2 things to say it's valid for that, and also modulus of x, modulus of minus x strictly is less than 1. We'll sort this one out first. That's the same as just modulus of x is less than 1. We'll sort this one out then. You can divide across by 2. You'll get modulus of x is less than a half. Okay. You have to say which one's more restrictive. So this one says modulus of x is less than 1. This one said, but modulus of x is less than a half. So this one is more restrictive. So valid for modulus of x is less than a half. Okay, folks, you're now ready to do the questions on the binomial exercise. Any problems, give us a shout.